Okay, sports fans, this is Naming Ionic Compounds Part 2. These are ionic compounds that have variable charge. What in the world does that mean? Well, think of kings and beggars. All of our metals, the peasants and the servants and the farmers, right, all had a low gem count and they wanted to get rid of them. They wanted to give those gems up and it left them with a slightly positive charge. Well, all the atoms that we've been dealing with so far have had the same charge every single time, right? A peasant always had one gem. The wizards always had 7 gems. Knights always had 6 gems, right? There are some elements on the periodic table that don't always have the same number of gems or the same number of valence electrons. And you guessed it, it is these transition metals in the middle of a table don't always have the same charge. So on our worksheet, we have some examples that we put boxes around, right? And the ones that have boxes around them, like 3, 4, 5, 6, 7, these are atoms that have a variable charge. And I want to teach you how we do the names for these, okay? We've got 2 examples on the board. We have CuBr2, which you might want to call copper bromide if we apply the first 2 rules of naming. And then over here we have CuBr, which you might want to call copper bromide. Should they have the same name when we have 2 different ratios? What's going on here is copper. Copper doesn't always have the same number of valence electrons. It doesn't always form the same cation. It doesn't have the same charge. So here's how it works. Here's the trick. We have to work backwards a little bit. And the key is to clue in on the non-metal. Bromine is really our clue here. When we look up bromine on the periodic table, one of the few elements that is a liquid at room temperature, okay? It's right here. Bromine is a wizard. That means it's got 7 valence electrons and it really, really, really wants to gain 1. When it gains 1, it becomes an anion that looks like this, okay? In both cases, bromine, when it has 1, 2, 3, 4, 5, 6, 7 valence electrons, it wants to gain 1 more. If it gets 1 more from copper, okay? I'll do that in a different color. If it gets 1 more electron from copper that it didn't have before, bromine becomes a bromide ion with a -1 charge. Okay? That's not anything earth-shattering that you haven't seen before. In both cases, with CuBr2 and CuBr, that's exactly what's happening. Okay? The bromide over here is also a bromide with a -1 charge. Okay? So then what's the difference? Well, here's what it is. Over here, this bromide ion got 1 electron from copper, which means that copper, when it got rid of that 1 electron, would have had a +1 charge. Well, a copper anion with a +1 charge and a bromide anion with a -1 charge, it only takes 1 of each for them to bond, have those charges cancel out to 0, and everything's great. 1 copper and 1 bromine. Okay? That means that our ratio of 1 to 1 is exactly what we need. So the name of this is not just copper bromide, but we use a Roman numeral to represent which copper it actually was. It was the copper that has a +1 charge. So we would apply rule number 1 and call this one copper. We'd apply rule number 2 and change bromine to bromide. Okay? These rules are in your naming booklet. But then there's rule number 3. Because copper has a variable charge, we have to put a Roman numeral in here. The Roman numeral represents what the charge is on the copper cation. And in this case, it's 1. So we call it copper, and in parentheses, we put Roman numeral 1. Sorry, that's kind of squished in there, right? It's copper 1 bromide, right? Now take a look at our other example. Over here, the bromide anion is still -1 charged, right? But we had 2 of them. Why in the world would we need another -1 bromide anion unless copper had more than 1 valence electron to get rid of? In this case, as a matter of fact, this bromide anion got 1 valence electron. This bromide anion got 1 valence electron. Both of them came from copper, but we only have 1 copper cation there, which means this copper had 2 electrons that it was able to give away. Okay, so that means this was copper with a positive 2 charge. All right, this is going to take a little practice. That just means in the name of this particular ionic compound, we still call it copper and bromide, but we need to represent the fact that the charge on this copper was a positive 2, not a positive 1 like it was over here. So we'd apply the first 2 rules like we normally would. And we'd call it copper, and we'd call bromide for the anion, but we need to put a Roman numeral in there that represents this is copper 2, the copper that has a charge of positive 2. This was the copper that had a charge of positive 1, and that's what those Roman numerals are in there for, okay? Let's practice it. Do a few more on your worksheet, try it out, and then come and see me if you're still stuck, all right?